Okay, class, now we go to semiconductor. First, you have to understand what is semiconductor. Semiconductor is something that the material that the resistivity or the conductivity in between in insulator and conductor. So you see that conductor is very good in conducting electricity, so probably the electron, you have extra electron, and insulator, you don't really have extra electron that move around, so we call it insulator. This one we call it conductor. So in between we have something that we call semiconductor. So semiconductor is material that the resistivity in between insulator and conductor. So the material that we use for semiconductor normally is silicon. If you look at silicon, the outermost shell it has actually 4 electrons. So we know that atom, they need to achieve duplet or octet so that it is stable, right? So 4, either it accept 4 electron or it donate 4 electrons, so it is in the middle. That is the reason that we call it semiconductor. Okay, so first you have to understand what is semiconductor, that the resistivity is in between good conductor and good insulator. Okay, so that is what we call semiconductor. Okay, so we have 2 types of semiconductor. One we call it p-type and another one we call it n-type. Okay, let's look about p-type semiconductor. P-type semiconductor. Okay, so if this is all silicon, and so on. Okay, all silicon. You want silicon, it have to combine, it have to share with another 4 silicon so that it got 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So if I drop in something here, okay, so p-type, let's say p-type, I drop in aluminum. Let's say aluminum is actually okay, P refer to positive, huh? Okay, so aluminum means that it has 3 valence electron. Okay, so aluminum normally has 3, 1, 2, 3, means that it has 1 empty space. So imagine here you have 1, 2, 3, 4. Here you have silicon, and then 1, 2, and another silicon here. Means that you have 1 empty space here, right? So when you have 1 empty space here, you see that all the electron, you see, electron will see, oh, there's empty space. Electron will start to drift around, go over to fill the vacancy, and then leave another empty space. So another electron will move around here and then leave empty space. So it also and happen in all those electrons. When there is empty space, electrons start to change place. So overall, you see that there is actually movement of electron. So when electrons start to move, means that that is already conductor, slightly conducting electricity, right? So how much conductivity that you want, you can actually control by the number of dopant aluminum that you want to dope into the whole piece of semiconductor, silicon semiconductor. So that's why you call p-type semiconductor, which means you have to understand P means positive. P means positive. So the major charge carrier here is actually Hall. Major charge carrier here is actually Hall. You see that Hall, because of Hall, so the electrons start to move around. And then the dopant here is actually something that we call it trivalence electron. Trivalence means that the electron, the outermost shell has 3 electrons. That's why we call it trivalence electron. Example of it, p-type is Big Apple. Okay, so Big Apple. So B, boron, indium, gallium, and aluminum. Okay, so remember, p-type, you have Big Apple. Okay, so what you have to remember here is that the major charge carrier here is Hall, the dopant is trivalent atom, and the example of dopant is Big Apple: boron, indium, gallium, and aluminum. Okay, so that is the example of p-type. Now we go to n-type semiconductor. So N refer to negative, so negative means that you have extra electron. Same thing again, I have silicon here, and then I dope something with 5 valence electron, 5. So you see that this one contribute by another silicon and so on. So I have 5 extra here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and then I have 1 more extra here. So if I have extra here, example of it is like arsenic. Okay, if I have extra electron here, means that it is 9 electrons at the outermost shell, which is not balanced, right? So this electron will start to fight for the seat, the proper seat. So the electron probably will push away this electron, and then it sit on here, and then you have one more extra electron, it will push another electron, and so on, so on. So you have overall movement of electron. So now it become a conductor that the conductivity actually can be controlled by the number of dopant. Okay, so when teacher said about N-type semiconductor, so you have to understand that the major charge carrier here is actually electron. Okay, so it's electron. It is due to electron. Okay, so the dopant here must be pentavalent. Penta means that 5, pentavalence atom. Okay, you have 5 valency electron at the outermost shell, and the example here is alpha. So you always have n alpha, right? And non-stop alpha that asks your teacher. Okay, so alpha is what? Is arsenic, phosphorus, and antimony. Arsenic, phosphorus, and antimony. You have to remember the example because this can be your objective question. Which of the following is actually example of dopant for N-type? So you have to remember that. So we have 2 types of semiconductor. One we call it P-type, one we call it N-type. And then you have to remember all the characteristics here. Okay, that's all for semiconductor. Thank you.